Good morning. I'm Dr. Sujita. Today I'm going to present the issues in ad hoc wireless networks. The major issues that affect the design, deployment, and performance of an ad hoc wireless system are as follows: medium access scheme, routing, multicasting, transport layer protocol, pricing scheme, quality of service provisioning, self-organization, security, energy management, addressing and service discovery, scalability, and deployment considerations. We'll see medium access scheme. The primary responsibility of a medium access control protocol in ad hoc wireless network is the distributed arbitration for the shared channel for transmission of packets. The performance of any other wireless network centers on the MAC protocol, more so for ad hoc wireless networks. The major issues to be considered in designing a MAC protocol for ad hoc wireless networks are as follows: distributed operation, synchronization, hidden terminals, exposed terminals, access delay, real-time traffic support, resource reservation, ability to measure resource availability, capability for power control, adaptive weight control, and use of directional antennas. Coming to routing, responsibilities of a routing protocol include exchanging the route information, finding a feasible path to a destination based on criteria such as hop length, minimum power required, and lifetime of the wireless link, gathering information about the path breaks, mending the broken paths, expending minimum processing power and bandwidth, and utilizing minimum bandwidth. The major challenges that a routing protocol faces are mobility, bandwidth constraint, error prone and shared channel, location dependent consumption, other resource constraints. Next is the major requirements of a routing protocol in an ad hoc wireless networks are the following: minimum route acquisition delay, quick route reconfiguration, loop-free routing, minimum control overhead, scalability, provisioning of QoS, support of time-sensitive traffic, security and privacy. And coming to multicasting, multicasting plays an important role in the typical applications of ad hoc wireless networks, namely emergency search and rescue operations and military communication. In an environment, nodes form groups to carry out certain tasks that require point-to-point and multi-point to multi-point voice and data communication. The arbitrary movement of nodes changes the topology dynamically in an unpredictable manner. The mobility of nodes with the constraints of power source and bandwidth makes multicast routing very challenging. Traditional wired network multicast protocols such as core-based rings, protocol-independent multicast, and distance vector multicast routing protocol do not perform well in ad hoc wireless networks because a tree-based multicast structure is highly unstable and needs to be frequently readjusted to include broken links. Use of any global routing structure, such as the link state table, results in high control overhead. The use of single link connectivity among the nodes in a multicast group results in a tree-shaped multicast routing topology. Such as tree-shaped topology provides a high multicast efficiency with low packet delivery ratio due to the frequent tree breaks. Provisioning of multiple links among the nodes in an ad hoc wireless network results in a mesh-shaped structure. The mesh-based multicast routing structure may work well in a high-mobility environment. The major issues in designing multicast routing protocols are as follows. They are robustness, efficiency, control overhead, scalability, and security. Then coming to transport layer protocol, the main objectives of the transport layer protocols include setting up and maintaining end-to-end connections, reliable end-to-end delivery of packets, flow control and congestion control. Examples of some transport layer protocols are UDP, that is User Datagram Protocol. It's an unreliable connectionless transport layer protocol. It neither performs flow control and congestion control. It do not take into account the current network status such as congestion at the intermediate links, the rate of collision or other similar factors affecting the network throughput. Then TCP. Transmission Control Protocol is a reliable connection-oriented transport layer protocol. It performs flow control and congestion control. Yet performance degradation arises due to frequent path breaks, presence of stale routing information, high channel error rate, and frequent network partitions. Next is QoS, quality of service, is a performance level of services offered by a service provider or a network to the user. QoS provisioning often requires negotiation between host and internet, resource reservation schemes, priority scheduling, and call admission control. This table shows the applications and the corresponding QoS parameter. Multimedia application, that is bandwidth and delay. Military application, security and reliability. Defense application, finding transworthy intermediate host and routing availability. For emergency search and rescue operation, it is availability. Hybrid wireless network, maximum available link life, delay, bandwidth, and channel utilization. Communication among the nodes in a sensor network, minimum energy consumption, battery life, and energy conservation. So then QoS aware routing, finding the paths in the path is the first step toward a QoS aware routing protocol. The parameters that can consider for routing decisions are network throughput, packet delivery ratio, reliability, delay, delay jitter, packet loss rate, bit error rate. One very important property that an ad hoc wireless network should exhibit is organizing and maintaining the network by itself. It is said to be self-organization. The major activities that an ad hoc wireless network is required to perform for self-organization are neighbor discovery, topology organization, and topology reorganization. Security is an important issue in ad hoc wireless network as the information can be hacked. Attacks against network are two types. One is passive attack, another one is active attack. Coming to passive attack, which is made by malicious node to obtain information transacted in the network without disrupting the operation. Active attack, they disrupt the operation of network. Further, active attacks can be classified into two types, external attack and internal attack. External attack, the active attacks that are executed by nodes outside the network. Internal attack, the active attacks that are performed by nodes belonging to the same network. The major security threats that exist in ad hoc wireless networks are as follows: denial of service, resource consumption, energy depletion. Then coming to buffer overflow. Denial of service, the attack affected by making the network resources unavailable for service to other nodes, either by consuming the bandwidth or by overloading the system. Resource consumption, the scarce availability of resources in ad hoc wireless networks makes it an easy target for internal attacks, particularly aiming at consuming resources available in the network. The major types of resources consumption attacks are energy depletion, highly constrained by the energy resource, aimed at depleting the battery power of critical nodes. Then buffer overflow, carried out either by filling the routing table with unwanted routing entries or by consuming the data packet buffer space with unwanted data, lead to a large number of data packets being dropped, leading to the loss of critical information. Host impersonation, a comprised internal node can act as another node and respond with appropriate control packets to create wrong route entries and can terminate the traffic then for intended destination node. Then information disclosure, a compromised node can act as an informer by deliberate disclosure of confidential information to unauthorized nodes. Then interference, a common attack in defense application to jam the wireless communication by creating a wide spectrum noise. Addressing and service discovery. Addressing and service discovery assume significance in ad hoc wireless network due to the absence of any centralized coordinator. An address that is globally unique in the connected part of the ad hoc wireless network is required for a node in order to participate in communication. Auto configuration of addresses is required to allocate non-duplicate addresses to the nodes. Then energy management. Energy management is defined as the process of managing the resources and consumers of energy in a node or in the network for enhancing the lifetime of the network. Then coming to the features of energy management, shaping the energy discharge pattern of the node's battery to enhance battery life. Then finding routes that consumes minimum energy and using distributed scheduling schemes to improve the battery life. Handling the processor and interface devices to minimize power consumption. Energy management can be classified into the following categories. Transmission power management, that is another one is battery energy management. Coming under transmission power management, the power consumed by the radio frequency module of a mobile node is determined by several factors such as the state of operation, transmission power and the technology used for the RF circuitry. Next one is battery energy management. The battery management is aimed at extending the battery life of a node by taking advantage of its chemical properties, discharge patterns, and by the selection of the battery from a set of batteries that is available for redundancy. Then processor power management. The clock speed and the number of instructions executed per unit time are some of the process parameters that affect power consumption. The CPU can be put into different power saving modes during low processing load conditions. The CPU power can be completely turned off if the machine is idle for a long time. Device power management. Intelligent device management can reduce power consumption of a mobile node significantly. This can be done by the operating system by selectively powering down interface devices that are not used or by putting devices into different power saving modes depending on their usage. Then scalability. Scalability is the ability of the routing protocol to scale well in a network with a large number of nodes. It requires minimization of control overhead and adaptation of the routing protocol to the network size. The deployed part of the network starts functioning immediately after the minimum configuration is done. So short deployment time. Compared to a wired network, the deployment time is considerably less due to the absence of any wired links. Then it is reconfigurability. The cost involved in reconfiguring a wired network covering a metropolitan area network, that is MAN, is very high compared to that of an ad hoc wireless network covering the same service area. That's all about the issues and challenges in the ad hoc wireless networks. Thank you.